Hello, everyone, and welcome to Trigonometry. Before we start discussing and learning this subject, let's have a short introduction. What is trigonometry? This word trigonometry, it derives from two Greek words. We have trigono and metri. Trigono, it's from the Greek word trigonon, which means triangle. And metri comes from metron, which means measure. Basically, trigonometry is about triangles. We're going to learn more about triangles. And here we have a another phrase here beneath the statement, or rather the phrase study about triangles, and that is sides and angles. So we're not only going to talk about what does triangle look like and other basic information about it, but we're going to learn more about its sides and angles. This is the visual aid of what triangle looks like. Be reminded that there are different types of triangles in terms of how they look. For example, this one. Another example, this one. Another example is this one. See, these are all triangles, all right? So the triangles here, you will know that it is a triangle when they have only three sides. Like the blue triangle, for instance, this is the first side, the second side, and the third side. So there are triangles. There are three sides in total. So the same thing here. We have one, two, and three total of sides of a triangle. The same thing here. One, two, and three, and here as well. One, two, and three. You see that? Now, let me erase all of the inks or the writings. Now, why do we need to learn about its sides and angles? Well, the first reason is the common reason, okay? And that common reason would be about, since we're talking about triangles, we're also going to talk about like their parts, their roles, their basically their purpose. You get me? So that's basically the common reason. It's like, okay, let's talk about the human body, like overall, like the human body itself. So here, we're not going to learn the general aspect or the general outlook of the human body, but but we're also going to learn the different parts of the human body, like the head, the eyes, the hand, so on and so forth. All right. So that's the first common reason. Second reason is that there is a relationship between sides and angles of a given triangle. All right. So first, let me tell you the purpose of sides of a triangle. All right. Yes, without the side, there will be no triangle, obviously. But other than that, the side of a triangle tells you the how should I say this? They tells you how long they are. All right. For example, this blue triangle, let's just assume that this triangle is an isosceles triangle or a triangle that has two the same sides. So let's just say the left side and on the right side are the same. So if this is 3 meters, then on the right, we have 3 meters as well. Then on the bottom part or the base of the triangle, this is different from from these two uh the same sides. So assumingly this is 5 meters. Okay. So again, sides tell you how long they are. Angles, on the other hand, they actually tell you the distance between the two lines. All right, between the two lines when they are spreading. So what do I mean by that? So first, let's locate where the where angle does. All right, let's locate where angle does. So angles are located at the corners of the triangle or at the vertices, in other words. Vertices is another word for the corners. All right. So here, Assumingly, this is angle A. On the top, this is angle B. And the bottom right, this is angle C. All right. These angles tells like how far the two lines are, despite that they are actually intersected at one point. Like for example, at the angle A, we have two. Wait, let me just use different pen color for you to get my idea. So for example, we have these two lines, right? This one and this one. Forgive me if my drawing is not that straight, but I think you get the idea. So we have two lines here, right? Two lines. Now, the thing is, we want to know how far they are, but not in a way that in a straight line like this or like this. No, we're not going to do that, but rather in a curved way like this, like how far they are. All right. Or just imagine that they are actually, let's just say, going outward to each other, right? Like, for example, we have this line, right? Okay. Just imagine that one of them rotates. So let's rotate this line outward. So what will happen here? We will have this as a result. All right. So that's it. That's a result. All right. And with that being said, the way how these two are, how should I say this, are far apart to each other, we can actually tell how far they are by the use of angles. All right. So that's the purpose of the angles. Okay. It tells you how actually far they are. All right. So now let's talk about its relationship. So you see, when sides are given, they can actually find the missing side of a triangle. And that's the same thing for the angles, because it is possible that it will happen. And there's also a possibility that if we have a given sides, we can actually find the missing angle, right? Like for example, like this is 3 meters, this is 3 meters, okay? Then let's just say we have a given angle here, which is let's just say it's 45 degrees, all right? But we do not know the side here. So what are we going to do? So there's a technique for this one, and we will learn this in the future. All right. So these two sides and angles, they actually are the important parts of the triangle. Not only that they gave us like the lengths and measurements, but they have the important role in solving a trigonometric problem like this, for example. So now I already simply discussed you briefly about trigonometry. What does it look like? Now let's talk about its application. What's the application of trigonometry in real life? Okay, now I want you to imagine this one. Suppose there is a 10-feet building approximately, and you are here. Now you're curious that how far, or rather, what would be the distance between your feet and the rooftop of your, of the building itself? You're curious. Okay, so it is just an ordinary line or a diagonal line to be particular. Now, you see, this one, if let's just say we have a given angle here. All right, let's just say the angle here, let's just say it's 60 degrees. Wait, no, it doesn't make sense. Maybe it's 45 degrees, right? 45 degrees. Now, let's find this missing this missing side. But how though? You only have this side, you know, the height of the building and the side that you need to find. So if you're going to draw that in different way, you have like this, and then you have a given angle 45 degrees. Here, we can now safely assume that you're actually forming a triangle. All right? You see what I mean here? You're actually forming a triangle here. Wait, let me just, all right, there you go. So 10 feet tall. All right, then you're asked to find this one. All right, then here, this is basically the distance between you and the building. All right. So you see my point here? This is another application of trigonometry. Another example, suppose you are in a certain park. You know the measurements of the four sides. You have this one as 22 meters, this one as 15 meters, 12 meters, and 6 meters. All right, imagine that this is your park. All right, you want to know how far this point and this point to each other. Assumingly, this is point A and this is point B. We want to know how far they are to each other. Now, if you're going to cut this segment, it would look like this one. Another triangle. So we have 6 meters, we have 12 meters. All right, this is point A and this is point B. We want to know the missing side here. All right, I think you already know how to find it. All right, if you think if it's a method that you use in solving a simple geometric problem or any geometry problems, I think you will understand what would be the method that you're going to use here. All right. So yeah, this is one of the basic applications of trigonometry. And lastly, let's just say that you have a directions which are north, east, south, and west. Okay. Suppose you have this one as your guide to tell you how far you've gone through. All right. So here you have a displacement, right? If you don't know, displacement is basically a type of distance, but with direction. So let's just say you started from here at the middle, then you reach at this point. Let's just say this is 60 kilometers. All right. And you have a given angle here. The angle here is 45 degrees. All right. Now, your job here is okay, you start from this point up to this point. It's basically the final position. Now, let's ask this to ourselves. All right. How far are we in that point, like this point, in horizontal components? All right. Horizontally speaking, how far we at that point? And okay, how about telling the distance between this point to this point in a vertical way? All right. So we are looking the distance of the horizontal component. Let x be the horizontal component and y be the vertical component. So here you can clearly see that I am forming a triangle here. All right. This one is another application of physics. All right. If you studied about vectors, I think you'll understand what I mean. There's some another example for this one, especially if you want to find the overall displacement of, let's just say, of the how should I say this, of the two given displacements. Like for example, uh, at this point, you traveled, let's just say, 10 meters, all right? And then the angle given here is 30 degrees. Then you stop right here. Then after that, you traveled at this distance. Let's just say, not distance, displacement, I mean, which is, let's just say, this is 12 meters, all right? And then the angle formed here is actually 60 degrees, all right? Then now you stop right here, like at this point. So how far you are from the starting point up to the finishing point. That's it. So you form another triangle. All right. So we will discuss this one in the future. And now, speaking of discussions, what are the topics involved here in the trigonometry? So here are the topics that we will be discussing in the future. So first, let's talk about angles and angle measures. So remember I mentioned about degrees, right? So here we're going to learn about degrees and radians, the length of a circular arc, then we have linear speed and angular speed. Now, here's the thing though. We're talking about triangles. Why is it that we need to learn about circular arc? You know, why is it important? We will learn that in the future. All right? Then here we have linear speed and angular speed. All right? Why do we need still to discuss this one? Because overall, this is basically a physics topic, but it also involves the application of angles and angle measures. So we will learn more about that soon. Then, the second topic we'll discuss is a unit circle. So similarly to what I just said earlier, we're talking about triangle here. Why does it involve circle? So the same thing here. Why do we need to discuss unit circle? So here you will learn the application of trigonometry to to an unit circle. Third topic is right triangles. So here we will learn more about right triangle. So here we will have Pythagorean theorem, trigonometric ratios, and we have angle of elevation and angle of depression. Another topic is we will talk about graphs of trigonometric functions. If you think that the graphs of a trigonometric functions are triangles, then you are wrong. And you will know that in the future. All right. Then next we have the graphs of inverse trigonometric functions. In here, uh, if we have trigonometric functions, then there's actually an inverse of it. So the inverse of it is called inverse trigonometric functions. Here we have another topic that talks about other types of triangles. All right. So here in other types of triangles, that means that if we discuss right triangles, how about the other types of triangles? So here it involves law of sines, law of cosines, law of tangents, and then the applications of using these techniques, or rather these subtopics. Then next, we're going to talk about the area of a triangle. In geometry, uh, we learned that the area of a triangle is actually one half of the product of base and the heights of a triangle, or one half times base times height, or it would look like base times height all over 2. All right. But let's just say that, the height is missing or the base is missing. So how are you going to find the area of a triangle? So we will know that in the future. Let me just erase this writing. Then next, we will have trigonometric identities. So here we will learn about what are the important, how should I say this, important formulas that you're going to need in this topic. So we have the common identities or the common formulas that you need to memorize and familiarize. Then you have to know how to verify the trigonometric identities. Then here we have compound angles. So here, you will learn more about what if in a, excuse me, what if in a given trigonometric function, you have a given of compound angles. When I say compound angles, it doesn't involve only one angle, but more than two angles. So here we will have a lot of subtopics here in the compound angles, which are sum and difference, double angles, sum or difference to product, then product to sum or difference, power reduction, and half angle. And last two topics that we will discuss is second to the last, trigonometric equations. So you see, before when we learn about algebra or geometry, we know about equations, right? So we're going to find the how should I say this? Find the missing value, find the x, find the y. So similarly, we're going to do the same thing in this topic, which is trigonometric equation. And lastly, trigonometric form of complex number. So here it involves imaginary numbers and how it is applied with trigonometric subjects, or rather trigonometric topics. So yeah, that is all, and I hope I could help you in learning trigonometry. So see you soon, guys.